Hello, my name is Michael Musembi, and in this video, I'm going to do a demo of malaria prediction system. So from that, I think we'll start from the homepage, which is where you just see malaria predictor and also predict malaria incidence rate based on water sanitation and data. From this, we're going to start the prediction. For this, you have to input, say, urbanly safely managed water, say 85.66%, then rural population growth from, say, 2.7% population growth, then, and also in the rural, we can do a 78.8%, then in the urban areas, we could say uh, 86.5%. For basic sanitation services in the urban area, we could see 87.5%. Then after that, we can do predict, and this one, so the predicted malaria incidence is said to be around 185.29 per 1,000 population at risk. So for every 1,000 population, we have like a risk of 185 people contracting malaria. So this one has the risk interpretation where you can see the low risk, moderate, and high risk. And also we can see the input summary. From that, you could always do like say a new prediction, or you could go back to home. Once the user submits the data, the app sends it to the deployed FastAPI endpoint and returns a malaria incidence prediction per 1,000 people. So from that, I think we can see from our API service.dat. So from that, I think we'll go to our Swagger UI. Okay, this is the Swagger UI, and say post, then predict, for example, then this is the Swagger UI. Then for this, you can see the values and all that. And if you execute it, you're going to get you're going to see the JSON response from here. Yeah, this is the Swagger UI of the same. And from that, we could go to the notebook. So basically for the notebook, this is the notebook importation of NumPy, Pandas, Matplotlib, and random forest, and also decision tree regressor, and also linear regression. So after that, I loaded the dataset, which is the malaria dataset, an African one. And after that, I saved the model and Scala to files. Then I downloaded the files, which is malaria model and also the Scala model. After that, checked for the missing values in the dataset and also the basic info of the dataset, which is this is the output. And after that, basically dropped the columns with too many missing values or also the irrelevant features, and cleaned the data. A correlation heat map of the data that I had. And after that, you can see we could see the distribution of malaria incidence. This is the distribution of malaria incidence. Then the relationship between the bed net usage and malaria incidence. So this one, we could see the bed net usage and also versus malaria, the relationship. And after that, selection of features with the highest correlation to target, then created the final data set. And for the final data set, you can see I did the prediction, the evaluation, then the implementation of custom training. So I can see the learning curve where the training and also the testing. Then I also did the scatter plot, the before and after scatter plot. You can see the before actual values and the after prediction versus actual. So after that, you did the linear regression, decision tree, random forest, and also compared the results. So with that, I decided to go with random forest since it's the one that performed the best and served the Scala and also saved the feature names. Yeah, so this is how I did train the model and that. So from that, I think we could go to a little bit of the Flutter app where we can go and see, say the screens, say the input screen. So this is the input screen. This is the code behind the Flutter. So I've, to summarize, I've basically deployed a random forest-based malaria prediction model using FastAPI, connected it to Flutter mobile app, and the app validates the input, fetches real-time prediction, and Soga UI helps with testing and validation of API inputs and output.